Okay, so for this next video, for this next example, we have a point that is definitely not on the unit circle. So it has coordinates that are pretty far out there, and it's on the terminal arm of some angle that we don't know in standard position. And what we have to determine, sorry for this crowded writing here, but what we have to determine is secant of theta. And as a reminder, secant of theta is really just the reciprocal of cosine of theta. And if cosine of theta is x over r, secant of theta must be r over x. So this is what we have to find. This is our goal, right? Sometimes there are so many different definitions, especially in the beginning of trigonometry, and you're just trying to get all of those definitions and relationships between definitions straight. And so it can be easy to lose track of what you're looking for. This is our goal, right? We want to find what is r over x. What is the value of that? Okay, so how do we find that? Well, one thing that we know actually is we know if this point is at 24 and 7, we know that the x coordinate is really just 24. So we actually already know that this is just going to be the r value over 24. We really just need to find the r value here. We know that the y value is 7. We don't know what the r value is. It might help to draw a picture to show you some way of finding the r value. So let me estimate visually where point P could be with relatively similar scales on my x and y axes here. So here I have an x-axis, here I have a y-axis. So I'm going to draw this point. So let's say this is point P. I'll draw it a little below. This is point P. It's at where x equals 24, y equals 7. So this is our point P. This is lying on a terminal arm. This is lying on a terminal arm of some angle theta in standard position. And we don't know what the angle is, but we don't have to, because what we might realize after drawing this picture, just drawing it, it's called an altitude, drawing a line straight down till it hits perpendicular to the base of the triangle. So we have this perpendicular line that we've drawn. It's perpendicular. Now we have a right triangle. We know the length. We know the height. It's just going to be the y value. But we don't know what we're calling the r value, right? What is the corresponding radius of the particular circle that we could draw? Or you could say, what is the hypotenuse, right? What is the length of the hypotenuse? And we have a Pythagorean theorem that helps us here, right? We know that a squared plus b squared equals the hypotenuse squared. In this particular case, we're just going to have x squared plus y squared equals r squared, where x just represents the length of the base, y just represents the height, and r just represents the hypotenuse, or the radius of the corresponding circle that we could draw. So let's just plug in our values. We know that the x coordinate is 24, and we know that the y coordinate is 7. And so all we have to do is just sort of a relatively elementary application of the Pythagorean theorem here. We can just find what 24 times 24 is, and that should be 576. And 7 times 7 is 49. And so r squared is just equal to 576 plus 49, which should be 625. And all we have to do at this point is algebraically solve for r by taking the square root. So we can say r then is really just 25. Right? 25 times 25 is 625. This isn't our final answer. But this helps us get to our final answer, right? Because really we were looking for the secant ratio for that particular angle in standard position. We know that the secant ratio is r over x. We already knew what x was, and then we use the Pythagorean theorem to find r. So what is secant of theta? I've written it in two different colors here, but secant of theta is really just 25 over 24. This is your answer. Right, maybe I'll make it more clear. Secant of theta, we don't know what theta is, but we don't have to, because we know the coordinates of some point P that lies on its terminal arm. So we don't even have to know what theta is. right, we can still find the ratio for the secant of that angle in standard position. It's 25 over 24. There you go. And I'll see you for some new content in the next video.